Hello and welcome to the 16th iteration of the webinar series, number 16, E-ARK Validation, What's Inside the Package. My name is Pavel Stek and I'm the onboarding manager for eArchiving, the eArchiving building block. It's good to have you all here with us on this gloomy Brussels morning. In the last webinar, my colleague Tom had the sunshine on his face, but I don't have such luck. And so without further ado, let's start with the agenda. As I said, my name is Pavel Stek, part of the Ceph Stakeholder Management Office. I'm also the onboarding manager for eArchiving. We have a slightly shorter than average webinar for you today. And as usual, we will start off with Dr. Jamie Kaminsky, the eArchiving building block training lead. He will give the short introduction on the eArchiving building block. Then we will go on to the eARK validation part of the webinar with Carl Wilson from the Open Preservation Foundation and Costas Simatos, who works alongside him. And then we'll finish off with a Q&A session at the very end. Just a little bit of housekeeping. There is a question and answer portion on your Slido page on the right side. So please type in your question. We would prefer that you type in your question anonymously. And we do have a team that monitors that question and answer page section on that page. So we will get to it at the question and answer portion of our webinar. So without further ado, let's go on to the main crux of the webinar. So we always start these webinars with a quick overview of the building blocks funded from the Ceph program. But as you may also know, this program does conclude this year, and we are waiting for the conclusion of the discussions to launch the digital decade. So in essence, the first work program for the Digital Europe program can be published at any moment. We are waiting for the how and where the building blocks will fit in this program, and we will let you know as soon as more information does become available. Any and all relevant specifications, sample software, and relevant stakeholders of the building blocks can be seen here on your screen right now. And they are also featured on the Ceph digital platform, which you'll see the link on the bottom of the screen. I will not go into too much detail on these building blocks individually, as we have done so in every webinar up to this point. But if you do have any interest in any of these following building blocks, please go to the Ceph Digital website. This is a fantastic resource, and a lot of time has been spent to make sure that it is as accessible and easy to use as possible. As we go, and as you see on the next slide, this is just some basic rules and approaches to know if you do find a building block that matches your interest or organization's requirements. Each building block has a team of people that are ready to co-develop solutions and partner with you to help figure out your needs, whether it be to build a solution from scratch based on a European standard, buy a compliant solution from the market, with the standards being marketized and adopted by market players, or you can reuse sample software provided from the same Ceph Digital website link provided in the previous slide. The key message here is that the building blocks are indeed underpinned by European and/or international standards linked to large-scale member state initiatives or to European legislation. And with that quick introduction to the Ceph building blocks, as I said before, some of this may be invalid, or when the new work program does come out, a lot of this may change, but this is the crux and the basis of the Ceph building blocks as they are today. And so as my portion comes to a close, I am passing the floor to Dr. Jamie Kaminsky, who is the Ceph eArchiving Activity Lead Training. The floor is yours.
Thank you, Pavel. Thank you. That was great, as always. So as Pavel mentioned, I'm the Head of Training for the building block. So welcome everybody to what is the 16th of our training webinars, and actually the penultimate webinar of the season. So today we're going to be looking at e-archiving validation. And to do this, we have Carl Wilson from the Open Preservation Foundation and Costas Simatos from Digit. Now, as regular listeners know, I usually say a few words of introduction, but I promise I will keep it brief today. So, as by now many of you know, the e-archiving building block provides specifications, it provides software, it provides training, knowledge to help organizations preserve and reuse digital information over the long term. Now, all of this can be found on the building block website, and like Pavel said, we've put a lot of time into this, so do have a look. The link's on the screen here, but I'll also put the link in the chat box after I've finished speaking. Next slide, please. So in terms of what we do, we provide a variety of e-archiving services. We maintain technical specifications. We provide open source tools that you can download and use straight away. We have validation services that ensure that specifications are followed correctly. And that's what we're going to be talking about today. We've got a service desk, and again, I'll provide the link for that later. And we have outreach and community engagement activities. Also, we have training. And our training offer consists of webinars, video training online, and modules on the Moodle platform, amongst others. There won't be any face-to-face training this year. Next slide, please. So what I'd like to do is just spend a moment or two telling you about the final webinar in the season, webinar 17. So this is in 3 weeks' time on Thursday, the 21st of October. And that's going to be about e-archiving geospatial records. And it's going to be in 2 parts. We'll start with a sort of general introduction to specifically to the e-archiving content information type specification for geospatial data. And then we're going to go slightly more practical, slightly more technical. We're going to use questions from actual adopters as a sort of means to explain the specification in more detail. So this is going to be quite a practical session. It's going to show you how you can start using the specification, and we'll also look at some of the challenges that that you may face when adopting the specification and how they can be mitigated. So really quite an interesting session overall. But I'm really pleased to announce that for this session, we now have Ann-Kristin Egeland from the Danish National Archives doing the technical part of the presentation. Now, Ann-Kristin is one of the key developers of the specification, and she'll be supported by Gregor Zvaznek. So this really promises to be quite an interesting presentation all round with things for sort of all levels. Next slide, please. So as Pavel said earlier, the webinars will be recorded. They'll be made available on the e-archiving webinar page. And as you can see here, on this page, you'll have access to the PDF slide deck, recordings of the webinars. There's also, if you look in the sort of right-hand column, you can see the anonymized questions and answers. So if you ask a question today, we will anonymize it, transcribe it, and make it available for the community as part of the training resource. Next slide. You can also find our recordings, so the recordings of the webinars. They're also on the Seth Digital Connecting Europe YouTube channel, and this is a really I think it's a fantastic resource because it doesn't just have the e-archiving material, which is great, but it also has material from all of the building blocks. So you can get a really a good overview of what's out there in terms of resources and services from the vast range of building blocks. So this is a great resource to look at if you've not done so already. Now, in terms of communications, we've got a LinkedIn group, and you can see the details on the screen here. We've also got a Twitter handle. So as I always say, if you haven't signed up to the social media already, then please do so. And speaking of communications, we're going to send a link for the satisfaction survey. So please do fill this out if you can. We do look at them, and we do take note of what you say. So they're really helpful for us. So please do complete the satisfaction survey, and we'll post the link later. So next slide. So this is my final slide, and my favorite part of the introduction, and that's introducing our speakers. So today we're welcoming back Carl Wilson from the Open Preservation Foundation and Costas Simatos from Digit. Carl, our opening speaker, he's the technical lead who oversees the Open Preservation Foundation's technical activity. He's also the E-ARK Validation activity lead, which is really why he's here today. And as you remember, Carl and Costas did a webinar in October last year, and they're coming back today to update us on the latest developments in e-archiving validation. So Carl, it's over to you.
Yeah, thanks, Jamie. Yeah, my name's Carl Wilson. I'm technical lead at the Open Preservation Foundation, and I'm also the activity lead for validation, compliance validation on e-archiving. I presume people can see my slides. Okay. So yeah, I'll be giving the presentation today. Costas actually is responsible for the CEF testbed, which is an extra implementation. We'll talk a little bit about that, and he'll be taking questions if there are questions about the Seth Testbed. But I'll be the main person giving the presentation. Okay. So just an overview of what I'll be talking about today. We'll be first just taking a look at defining some of the terms we use in e-archiving and in this webinar. Some of these actually frame where we are at the moment, and actually where some of the specifications are, and how detail is added by layering specifications and a journey from compatibility to interoperability. And then we'll take a look at the validators or the new validator at the end. That's an update of the existing validator. There's a new REST interface. We'll be giving a quick demonstration and look at some of the improvements that have been made and one or two of the things we would like to do going forward. Okay, so with no further ado, I'll start by looking at we'll start by looking at some of the terms that we'll be using. So we use these words. There's a bunch of words we use quite a lot in eArk: compatibility, interoperability, specifications, and standards. And yeah, I'd like to just kind of describe our view of those terms. It's easy to use words, and people sometimes misunderstand or words used ambiguously. So in short, we look at compatibility as software and data that can get along. They'll work. They don't work necessarily interoperate. They don't work together, but they won't break each other. Interoperability gives us software and data that work together. We'll look briefly at specifications and how they provide for compatibility and interoperability, and then finally a standard, which I just view as a specification that actually gets used. What makes a specification a standard use? So starting in particular with compatibility and eArk. So we're looking at, as I say, we look at that as really software and data that can get along. So this is software and data that are compatible, that they can be used together without things breaking. But this can often be achieved through permissiveness and ignoring what's not understood. So it's easy to have things that are compatible if elements have been told to, if you find something you don't understand, be relaxed, be generous in what you accept, ignore and move on. So it's possible to have compatibility without very much interoperability. And when we talk about interoperability, which is our real goal in EARK, and we are talking about software and data that can work together, systems that where data can be shared and used to add value, where actually the data structures aren't just, you don't get it's not a top level view, you understand, where there's some deep understanding of the data and that's metadata that's passed between systems. And what we find is the greater the specified level of detail, the more interoperability you get, obviously. So interoperability requires detail. And in EARK, we've produced a lot of specifications. We talk about standards, but actually what we produce is specifications. And the specifications are a detailed description of the design and arrangement of data, which could be a file format, etc. And in particular, our specifications concentrate on information packages, archival information packages, as defined by OAS. So these specifications, they become standards through authority and use. A good specification and it's something of a tightrope when you're designing specifications. They should be generally applicable enough for meaningful adoption in the domain. So if a specification is so detailed and so tight that it fits very narrow use cases, that tends to stand in the way of adoption. But it's also got to be specific enough to allow for interoperability between adopters, particularly in our case where we're looking to provide an interoperable layer. And this is where it becomes a tightrope, because you're trying to write specifications which are generally applicable to, so that adoption is straightforward for people and your audience, your target audience, is as wide as possible. But you're at the same time trying to be specific enough to allow interoperability, at least compatibility, and ideally interoperability between adopters. And the solution in EARK to that's been to make our specifications modular and extensible. So you start with the more generally applicable specifications, and these allow implementers to start fairly straightforwardly and try to progress from there. And a final word about standards, because as I say, with this, standards are talked about, and there are processes for getting a specification made a standard. The most famous one would be the ISO process. But is certification really what turns a specification into a standard? I would argue not. And actually, it's use that turns specification into standard. Standard is just that. It's a standard because everybody does it that way. So yeah, to be clear, when we talk about EARK standards, they really are specifications until plenty of people use them and they become commonplace. That's what turns a specification into a standard, nothing else. Okay. Now, just looking at how these terms then interact, because compatibility is often achieved without having to provide an extensive detail. And a set of terms have become so commonplace when talking about compatibility that there's even the language has even made its way into when you talk about compatibility, for instance, plug and play. So the plug and socket is almost one of the canonical examples of specification and standardization. And compatibility could be looked on as a plug that fits a socket. It's therefore compatible, they will play together. But the truth is, I would look at whether it's interoperable as a slightly different matter. Interoperability probably depends on, sorry, I've just got the wire from my headphones trapped around my chair, sorry, that's better. So what if the voltage is different, or the amperage, which pin is the earth? So although a specification, a less detailed specification provides compatibility, it may be quite dangerous to assume that things are interoperable. Sometimes superficial compatibility can even be dangerous. So would you want a plug that's compatible if actually the voltage, amperage, pin arrangements were different? No, you'd probably want one that didn't plug in. Another example would be refilling nozzles on petrol stations. Again, when they changed so that diesel and petrol weren't incompatible, it stops people putting the wrong petrol in the wrong tank. So what you need for interoperability for real interoperability is a level of detail and a level of completeness in the specifications. And as I say, what we've tried to do is achieve this by, rather than going for huge specifications, modular specifications where each layer provides another level of detail. And finally, I would just like to plug these specifications a little and give you some reasons why you might want to use public specifications. The advantage, I mean, the hidden advantage is, rather than just the interoperability or compatibility with other software systems and data stores, but the advantage are really that it allows you to build on the knowledge of others. There's plenty of people who know more about information packages than I do, have thought long and hard about some of these specifications. And there's bound to be things in those specifications that you hadn't thought about. Now, you may well think of things, the opposite may well be true as well. There may be things that aren't in the specifications that you have thought about, but then you have the chance to contribute. So everyone who uses a public specification has the chance to contribute and improve them. And again, this allows people who adopt them to build on your knowledge as well as the knowledge of the others. And finally, a cheap shot where you don't have to write all of your own documentation. You have to write some, but much of the documentation and rationale behind the decisions made is already documented for you. Okay. And in this section, we're just going to have a look a little bit about the eArK specifications as I've described them, how they build up in layers to take you from compatibility through to ideal interoperability. And one slide at a time. So there's the eArK specifications, as I say, are modular and they're layered on one or the other. So we have the base specification is called the CSIP, the Common Specification for Information Packages. This is the root of, at the moment, two of the specifications. I'll talk about the AIP one separately, because at the moment that doesn't have a compatible specification or a validator. But the CSIP is the foundation for the archival package, the different archival package standards. So the SIP and the DIP, and the next version of the AIP specification is also compatible with the CSIP. And then on top of this, we've then, for the fine look for deep interoperability, we layer on what are called SITs. These are content information type specifications, and they provide detail at a domain level. And I'll say a little bit more about them in a second. So the CSIP provides roughly 130 rules, but then there are 150 requirements, but then there are a special set of restrictions for SIPs. They have an extension set of 35 requirements, which override some of and further restrict the 150 CSIP requirements. And unsurprisingly, these concern themselves with submission style concerns, things like submission agreements and data. And DIPs also get their own set of rules, but this is very minimal. It's only an extension set of 5 requirements, which again overrides some of the CSIP rules or extend the CSIP rule set. And the reason the extension set's minimal is these are actually derived generally from an AIP, so they don't tend to add too many new things. A DIP doesn't add too many new things to a package, whereas the SIP specification is fairly long. Now we'll have a quick. I've talked about the AIP. As I say, at the moment we don't have a compatible AIP specification. The AIP specification has been has had some problems for various reasons to do with the initial form we picked for it, the fact that it was seen by implementers as telling them how they would have to implement the storage layer in their own repository systems, which is not. It wasn't a mistake. It could be read like that. So the new version is compatible with the CSIP standard, and what it layers on top is basic archival information you would expect an archival system to add to an information package over time. And rather than being seen as a format that should be serialized to disk by systems, actually we're really looking at it as an export format from repository systems or a third-party a third-party format for a dark archive, so a particular node of your system that you want it to be in some kind of common format. If the repository system that you own ceases to work, the supplier disappears, etc. Any reasons why software that you use now may not be available in 5 to 10 years' time. And an updated AIP specification that supports this will be published in October 15. We can't promise that there will be a validator for that in the timescales for the project. Currently, that's obviously a very short lead time, but a follow-on project, or indeed more work that isn't funded, but we will still continue to work on these systems and these specifications and software and supporting them beyond the end of the project regardless. But obviously, without funding, the work may be slower. Okay. And then finally, again, as I say, a more detailed look at the role of the content information type specifications. These IP specification, the IP information package specification, so this is the CSIP, SIP, and DIP, they provide compatibility with what I would call a thin layer of interoperability. So the interoperability is what you would call a basic archival metadata level, key mets fields, for instance. But metadata, the metadata and content within the package, you would only describe as compatible. So the specifications describe where to put content and metadata of particular types and supporting documentation, but they don't place any restrictions on the format of any of the content and metadata in a package beyond the base mets file that are required for a package and representations. And the other metadata can be freeform. So as I say, this is why I would view these as compatible rather than interoperable. For interoperability, eARK provides what we call the content information type specifications, and these take us from compatibility to genuine interoperability. They provide detailed descriptions of metadata and the content. And when I say a particular domain purpose, probably the most detailed SITs we have at the moment is the CRD SITs for database preservation. So this provides detailed descriptions of the content and metadata that are required to archive database, the outputs of relational database systems, relational databases. The raw form may be Oracle, Microsoft SQL Server, but CR provides a common XML form that's used extensively in the preservation domain, and the SITs provides guidelines in where to place the CR derivatives, the metadata from those, which metadata should be present, etc. So, as I say, they provide genuinely interoperable packages rather than simply compatible packages. Next, I'm going to have a look at E-ARK validation, a little bit about compatibility, SITs validation, and we'll also talk about conformance and compliance with the Seth Testbed and how that goes beyond validation. So the first thing we'll start with is looking at what does E-ARK IP validation look like? It basically ensures that a package is structured properly. Most of the structure requirements are actually warnings. There are only two hard requirements. One is that if your package is in an archive format, i.e. zipped or tarred, that it unpacks to a single folder, and that folder is the root of the package, and that root folder must have one METS file. It doesn't care about other METS files and representations particularly. They may generate warnings, but they're the only two hard and fast rules. So a package is structured properly, or is certainly valid if it simply has a root folder and a METS file in that folder. Everything else is optional to a degree, although you will get an awful lot of warnings. The next stage of validation ensures that the master package metadata is well formed and valid. So well formed is done by simply running the schema checks for METS with an extension schema provided by eARK, but validity is this set of 150 to 180, depending on the specification, rules that are written in schematron, an XML language, that extend the basic, well, they go well beyond schema validation. These check that certain fields are present in the document. They don't tend to check the data types. That's handled by validation, but ensuring that fields are in place, that the right metadata and links are in place. And And these rules are actually published as a METS profile, but a METS profile isn't machine enforceable. So the schematron rules basically convert the METS profile into a machine enforceable implementation, and this can be run by any piece of software. We just apply the schematron rules ourselves within our software. It will also check some files to test for corruption if desired, but this can take a long time. And we've made 1 or 2 improvements actually to the validator API to allow this to be done in a slightly different manner that involves a lot less network traffic and takes less time. And finally, ensures that a package is self-contained and complete. And I've scare bracketed the ish at the end. I say that because some of the requirements in the EARK specifications are more ambitious than it's possible to validate. For instance, a requirement that states that the metadata folder must contain all the metadata for the package is impossible to enforce, because it's impossible for a piece of software to know what the complete set of that metadata for that package. So you cannot guess intent, but when we say complete, it can ensure that all files referencing metadata are present on the file system, and that all files on the file system have some metadata reference somewhere, or some reference somewhere, that they're not just an orphan file on the file system. So complete-ish, but as I say, you cannot know the intent of a package, what was intended to be in there by the creator. And if stuff that was in references drops, you would never know. Okay, then, so I'm going to give a quick demo of E-ARK validation, issues and detection. And at the same time, I'll be showing a basic package as we build up this package a little, to just basically to show what validity looks like. So on here, I'm going to use 2 screens here. One is the online validator. The other one is a command line file here, where the command line is, so the command, I'll explain what I'm demonstrating actually. So we have 2 implementations, a REST validator, which is about to be updated, but isn't yet. It will be updated by October the 15th. It supports a new REST interface. The rule set's the same, the errors returned are the same, but there's 1 or 2 smart ways the validator works. And as I say, I'll be demonstrating that alongside, this is the new version of the validator. This shows 1 or 2 of the improvements we've made. At the moment, I'm using it as a command line tool only. The reason it isn't, the validator parts work, the reason it isn't online for use at the moment is actually it demands a smarter client. So the JavaScript software to upload the packages needs extending for various features, and that's the bit that still is incomplete. But as I say, the deadline for that is the 15th of October. So what we're looking at here is command line. I will actually show you the show 1 of the packages at first. So the packages at the moment are held on disk, and they look something like this. If I just sorry. So we're doing this. So you can see that basically this package has a documentation folder, a metadata folder with some descriptive and preservation metadata, 1 representation, and some basic schema files. But what it doesn't have actually is a METS METS document. So if I simply try to then validate this, I get this straightforward location tells me it's in the root of the package. The information file must contain a file name XML, and this file must contain metadata that includes, and again, this file must contain metadata that identifies the package, provides high-level package description, and describes its structure. We can't muster all of that, and it's certainly not, that's intention again. We can check completeness for what's in the package, but as I say, we cannot check the intent. So it's possible we will reword the requirement, 1 or 2 of the requirements, so they're a little bit more specific there. But that's a broken package, and I can show you that the same package on the web validator. If I browse here, and sorry, no, I maybe don't have that one prepared as a zip. It's the next one. But what I'm going to show now is a slightly more developed package. This is actually a full eARK package has content metadata representing a sample Northwind style Microsoft database. So if I just give a quick, right, so here you can see we actually have a mets folder, we have documentation folder, metadata folder, representations for the various representations in a schema folder. If I just take it to the next, slightly to the next level, you can see in here that the documentation contains a diagram for the database, the submission, some supporting documentation for the submissions, and if I take it one level further, I believe, yeah, you can see that there is some metadata and schema files and some specific database metadata. So this is a reasonably large package. There's a diagram of this package coming soon, but I can then show you that. I'll show, this is where I'll show one or two of the improvements we've made to the validator API. So here, if I, so this tells me that this is a well-formed package. I have two warnings basically, and this should provide a descriptive metadata reference. It's two versions of the same warning, and it's simply about references to descriptive metadata. These aren't. This is a valid package. These warnings are, usually might highlight something that you maybe haven't thought of, but you can suppress the warnings and the package is still valid. They're more advisory than you have a problem with your package. And now let's just take a look at what that package looks like. So this on the main validator. So the difference between the implementations I will show you here. So this is the same package, simply as a zip file, upload to the validator. It takes a little bit of time. Again, you can see the same level of warnings, the same two warnings, and here the only difference is we've improved some of the location data. So the locations in the new version are certainly clearer. They provide a direct text path that will take you to the correct location, and will provide links to those within the web interface as well. So you can navigate from the problem to the location in the package. It can't fix things on the fly for you, but it will provide direct advice as to what you should do to fix any fix issues. Okay, I'm just going to find my slides. Right, yeah. Okay, I'm going to move to the next slide briefly, and we'll just have a look at it. So, just expanding the same points as I've demonstrated there. So, a valid package, eARK package, really doesn't require very much. It requires a package level mets file and some key mets fields filled in. With that, you can actually get a package that's genuinely valid at the structure and metadata level. And you get bonus points that are realized in terms of far less warnings for things like representations in dedicated discrete folders, metadata in dedicated folders, supporting schemas and documentation in dedicated folders. But they are simply warnings. They are just bonus points. A valid package really doesn't require much at all. Now we're just going to have a quick look at the idea of SITS validation. So the SITS, they add the meat to the IP specification bones. IP validation basically tells you that you have content and metadata and which is which, and says a little bit about the types of metadata involved. It also records relationships between metadata and content, but it says nothing about the form of either. A good SITS prescribes the form of metadata and the content in the package and provides relationships between the two. And here you can see the way that the specification is drilled down from the general to the specific. So we start with the common IP specification, add the layer of the specific information package specifications that share the common specification, and they are your minimal IP specifications. You could use one of the SIP or DIP specifications or the upcoming IP specification and be compatible with eARK and provide a layer of compatibility with other repository systems that implement or honor the eARK specifications. But if you want genuine interoperability, you're really starting to look at what we call the content information type specifications. And these provide domain or business specific specifications. And on top of that, you might layer your own local policy, local implementation. So you basically, this is a layer from the general shared specifications, and you can eventually fill in with local policy, local requirements, but you can build them on top of a compatible and eventually interoperable foundation. Okay. And this is the CR package that we actually just validated. This is the CR packet, the diagram, that CR package on the right. So you can see the layout here. And again, you have this idea of individual representations with their own METS file, CR data files, and then the binary files that are actually the original raw database files. The CR SITS provides another 33 rules on top of the 180 if you're using the SIP specification, for instance. And these cover general package metadata for databases, specific metadata types for database preservation, using CR as an archive format for databases, particularly which CR files you should be using and where you should put them, and also some guidance for splitting large database files as well. Now, I'll go back to that slide briefly. So in an ideal world, we would provide a validator for the CR SITS and one or two of the other SITS. They've been published quite late in the within this phase of eARK, so it would be, again, it would be a best effort to try to produce something from these either in the next phase or as a community project that will be it will get less dedicated time, but we will get there. We have the raw tools, which are the database preservation toolkit developed by Keeps. That actually provides most of the software you would need to build a validator. It really is a case of stitching the pieces together. Okay, so having talked about validations, I'm just going to define another couple of terms that we're using for how we see the future beyond validation. So the extra terms we use are conformance and compliance, and I'll just talk you through the definitions of these slightly. So validation really is the result of a validation test on a particular entity, and that's usually an information package in eARK, and against a formal specification. Yes, it's a logical yes/no result, although the presence of warnings and info messages do blur that a little bit. Yes/no is valid or invalid, but valid with caveats is also possible. So it really is a yes/no answer. You have a particular package, and is it valid at a particular point in time? Conformance we use to describe the level to which an archive or a particular software component conforms to specifications. And here, rather than just an information package that's produced, you would sample the outputs or the information packages stored by a piece of software, and you would try to get a representative sample. And you would validate each one of these in series. And if every information package you sample across different collections, the different information package types is valid, then the archive can claim a level of conformance. That level of conformance would really depend on how representative your samples are. Obviously, if you take one of each or a very small sample, you can claim conformance, but the claim's quite a tentative one. If you're happy that your samples are representative and provide good coverage of your collections and information package types, you can claim a fairly high level of conformance or a fairly high level of confidence in that conformance. And then the final term used is compliance. And this has been slightly woolly defined originally as is the term used when a digital archive or software component demonstrates evidence of conformance and further requirements. And we'll just take a quick look at what those further requirements might be and a platform that would actually allow people to perform this kind of testing. So first, just to say, to put these terms another way, validation gives a spot answer as the validity of an information package in a particular point in time. Conformance can actually be viewed as validity coverage for a particular software component. And the greater the coverage, the greater your confidence in the conformance. And compliance well, what might the further requirements to the above look like? And here I'm going to talk about something called the Seth Testbed service, and this is actually administered by Costas, one of our EARK colleagues who works for Digit. So the Seth Testbed provides a platform to test, verify, and monitor conformance and compliance. It's a complementary system to the EARK Validator, although it builds upon the EARK Validator. And it calls the EARK Validator. It doesn't provide its own validation layer, but it defines what it's capable of doing is defining test scenarios that can provide some context, ensuring that an archive is not only valid and conformant, but they also match a set of test scenario expectations. As Costas points out, the current setup in the testbed, it's more of a proof of concept as it passes the test to the validator and reports on the validation results. What it really needs to expand this functionality are scenarios, which we've discussed one or two, but we haven't implemented any scenarios as such at the moment. And these scenarios should have test cases, and each test case is expressed in a different scenario. Sorry, there's several test cases, and each test case will be expressed in a different scenario. Just to say that the access to the testbed is account-based, you have to actually have an account on the Seth platform, an EU login to actually use it, and it's available at the URL shown. What I'm going to do is just have a talk through a demonstration scenario to give you an idea of what this kind of compliance checking might look like. So compliance could be tested using established scenarios, and here's an example scenario. So a SIP consists of a sequence of TIFF page scans that make up a document. And that SIP also contains enough structural metadata that places those TIFF masters in the sequence and provides descriptive metadata, etc. But the policy states that on ingest, the repository creates a PDF of the JPEG conversions of the master images and provides that as an access copy, and also specifies the technical metadata that should be derived from the TIFF masters, any technical metadata that should be generated for the access copies, and the recording of the conversion process as well. So it's the definition of that metadata set that should be created by the process and placed in the correct sections of the information package, plus the content, which again should be generated as separate representation, put in the correct place in the information package. So that gives you a before package and an after package. And compliance testing actually means what you do is you ensure that not only is the before package and after package valid, but the produced package, the after package, has the correct artifacts in the correct places. And this could be quite high level testing. It may be just that you have to put some descriptive metadata in. You don't say what type of metadata that is, but a detailed scenario for interoperability would almost certainly say, and you should generate this sort of technical metadata for the conversion process, or this particular set of metadata for the PDF. So yeah, once again, detail provides you the confidence for interoperability. Without that level of detail and specification, you are really only talking compatibility, not interoperability. And as I say, compliance would be a layer beyond that, because it really is looking at elements of the archival lifecycle and ensuring that the before and after cases fit strict scenario guidelines. Okay, then. We're quite close to the end of the project now, but I'm just going to have detail what is coming. So the Commons IP, which is a Java validation library, we run two libraries, a Python one and a Java one, to support different types of, or different implementers, different software suppliers as well, people who want to incorporate the libraries within their own software. So the beta for the new version of Commons IP is out now. It was released earlier this week. And the updated REST validator and Python library will be released by the 15th of the 10th, maybe a little earlier than that, but certainly no later than that. And the REST point will remain in the same place. And we'll provide also a Docker image, so you can run the REST services locally, and a Docker CLI. And I should have put one of the URL in here. So Docker CLI, so this is a Docker image that allows you to run the command line. I should have put one of the URL in. I will share briefly my screen so just you can see it. We will be publicizing this come the release. So the other thing we have is the full REST documentation for the new API. It's a much more extensive API than the previous version. And one of the things this API allows you to do is, I said I'd talk briefly about it. I forgot when I was running the demonstrations, but I'll know how I can mention it now, is submitting information packages across the wire is quite heavy work. The content files, particularly, for instance, the database information package alone can have many gigabytes of data. And actually, for most of validation, E-ARK validation, that data isn't required. It's only really for confirming the presence of files on the file system and generating checksums. So the new API actually allows you to take a halfway house, and this is the need for a clever, a more advanced client. The JavaScript client generates what's called a manifest of your package, which is simply a list of the directories and files found in the package and their checksums, plus the metadata files, which tend to be text files and fairly light. And it pushes this skeleton package to the REST service, which means large packages with large content sets can still be fairly easily transferred and validated. But to do that, it must generate the package manifest locally using a Node.js JavaScript library. And it's actually just the finishing the implementation of the library that we're working on now, which should support the new REST validator. But this should allow people to actually validate packages of significant size without having to upload huge amounts of content to a third-party site. There's also the issue with content of not wanting to push content that you're not allowed to share to a third-party site. We don't store any data on that site anyway, but again, the new manifest pushed version would allow you to avoid it. It's simply the checksums of your content and a set of metadata that you're sharing. And yeah, there'll be an E-ARK announcement for those. I'm sorry they weren't ready to demonstrate for this webinar, but the webinar program set in stone a long time ago, and the development timelines can be a little variable. But as I say, the 15th, it will be done by then. That's the end of my presentation. I'll hand back for questions and wrap up. Thanks.
Thank you so much. Thank you, Carl. That was indeed very, very, I mean, for a short period of time, that was very comprehensive. I am looking at the chat right now. I don't see any questions. There was one question posted, but I hope we answered that sufficiently in the reply. If not, could you please give a clarification on that question? I do have to say thank you to Jamie as well. Your part was also very useful, and I would like to say that I did place the satisfaction survey in the chat. It is highlighted at the very top of your screen in blue. And so with the end of this session rolling around, we would like all of you to fill out this survey. Carl, I think you have done such a fantastic job. No one has any questions. Jamie, would you like to say a few words while people are thinking about what to ask?
Yes, just to reiterate what you said about the satisfaction survey. Also, well, again, to thank Carl for his time. Yeah, obviously we're looking forward to seeing you all again in 3 weeks' time for our next webinar on the geospatial specifications. That we're looking at a sort of 1.5 hour session for that, sort of with 2 speakers, one one doing a general introduction and one doing technical. So there's something for everybody there. We have a question.
We do, yes.
Mm.
How much does running checksums slow down the process currently, and is there a timeline for improving it?
That's a question that's slightly nuanced. So there are a couple of checkpointing points. So the first answer to that question is it depends how much content you have in your package, and how large the files are. So there's two issues: the number of files it has to do, although that's not really the bottleneck. The bottleneck is if you have a 300 gigabyte video, for instance, in your package, that will take a reasonable amount of time to read and checksum. It can be improved by chunking. It can be improved by providing threads, although most checksum algorithms, unfortunately, are fairly single-threaded because you have to feed each block of data after the other in sequence to generate the correct checksum. So it depends on the hardware, it depends on the size of the data. And the timeline for improving it really is this idea of pushing some of that. One is that you don't need to generate checksums to validate a package. That's the first thing. You do if you want to validate the manifest, but structure and metadata validation can be done without generating checksums at all. And the other idea is this idea of pushing a manifest. Now, you can generate that manifest whenever you want. So although I talk about a client that will generate the manifest for you, the Python command line tool will also generate a manifest from a package for you. Once that's created, you can push that up when you want. So that will depend on the client resources and the resources you had locally to give it. So there are various ways of improving it, or measures you can take to improve this, but really it's a case of compute power and the amount of data. And so there's no hard and fast answer. Yes, there is I'm sorry, I'm looking at some of the other questions now. Any recommendations for software to handle schematron? So our software handles it, obviously. The validator handles these schematron rules. Oxygen, the XML editor, I believe does a reasonable job. I've also used as a command line tool something called XML lint, which is available on Linux, and I think is available on Windows. But XML lint does a pretty good job of applying schematron rules and schema validation as well. So if you're after the third-party tool, XML lint or Oxygen, if you're just to run our schematron rules, well, you could use the validation software. Also, I can provide code links as well for calling schematron from Java and Python if that's what people want to do themselves as well. Obviously, our code base provides good examples, and I'll provide links to those if people want them. Yes, there is a direct link to the schematron file rules for CSIPs. I can share. I will try and share that here now. Just give me a second, and I'll see if I can find that. If not, we can send it around in some kind of follow-up. Jamie, can we? That might be easier. But yes, there is a link.
All the question and answers will be provided to you, Carl, and Costas, and then you formulate them and then provide answers, and they will be available on the webinar series page, where you can scroll down and click on the webinar, and the question and answers will be on the right-hand side.
Yeah, we divide those rules up into 6 sections, I think, one for each section of a METS file. So there's actually 5 or 6. It also makes it a little bit easier to control the application of those rules. Yeah, sorry, yeah. I was reading another question, so I got sidelined by a question I didn't understand. It's probably best not to read them. But yes, yeah, there's I will provide links to those sets of files, and then there's the ones for the SIP and DIP that are layered on top of that as well.
Here's a question: is a different validator needed for each SITs?
A validator, you wouldn't need it necessarily. So the validator architecture allows you to layer these plugins on tops, but you do need someone to develop a module for each SIT. So yeah, and a module development of a new module is required. Now, do bear in mind that many of the rules in SITS validation are simply extensions to the metadata rules, so can usually you can usually be implemented by a schema. Anything from the METS file can usually be implemented by a schematron rule. We already have a schematron engine, so providing another schematron rule set's not the difficulty. But if you want to start doing things like validating specific types of metadata, validating formats of content files, or deeper checks, for instance, with a database, with a CRD representation, you may want to check that the data in the CRD file represents it's something like the original data, etc. Those kind of things will need different a different validation module to layer on top. So yes, SITs do need their own validator modules, but you don't need a different validator. The information package holds identifiers that let well, anyone reading the METS file know what SITs and specifications are used within it, so the validator can be applied from the contents of the METS file. Okay.
I'm still waiting for the clarification on that really long question.
Black changes my all activity.
I think there are benefits payment application, and I'm not quite getting it.
No.
I'm asking if you could split the question in half, if you can't fit it in one. But if I think the best solution for that question is if they could email the question to us, and then we could provide more answers. And I think that would be the best solution. But I think yes?
I was going to say, I'm not sure whether the can be used as a web application or even used command line is a question or a... So the answer to that is yes, we provide the software can be used as both a command line application and a web application, and there's a supporting library that's shared by both of those that you could use for your own applications as well. And we also provide Docker images for both of those that take the pain out of the installation dependencies, although you do need Docker installed to use them. Sorry, back to you, Pavel.
No, any explanation is good explanation, I think, in my book. But I see that the questions have stopped scrolling up, so I assume that everyone has gotten the information. For the people, for the question about the links, we will be updating the webinar series page, and the question and answers will be put up fairly shortly, and you will find all the links to be provided on that page. On that note, yes.
Sorry, I will provide one or two extra links as well. So
in the chat.
Yeah, the swag. Well, also, yeah, in some kind of follow-up email.
Yes,
yeah,
absolutely.
The Swagger definitions for the new API would be useful as well, and they're not in the slides. Yeah.
I guess on that note, the webinar is now wrapping up. Thank you so much, Carl, for your explanations, your diligence in answering questions, even before I got a chance to ask them. And also thank you to all of you who've sat through this webinar. It is our penultimate webinar, and we do have one more, so we hope to see you there on the 21st of October. Please register if you haven't registered, and we would like to see you there and to celebrate the end of the 2021 webinar calendar. Jamie, do you have any last words?
No, that covers it nicely. But we'd love to see you in 3 weeks' time. And thank you for coming today.